subject AC machines, code electrical 400 AC, topic single phase transformers, duration 50 minutes, subtopics is problems on transformer on load conditions. Here in previous class, so we learned transformer works and mutual inductions. Transformer works on mutual induction. Ideal transformer on no load and on load. Vector diagram. Now objective is on completion of this period you will be able to understand to determine the various currents of a transformer, on load at different power factors. So now go for example 1. A 2200 by 220 volts, 50 Hz single phase transformer has no load primary current of 0.6 amps and the power factor of 0.275 lag when its HV side is energized at rated voltage. If the secondary supplies a load current of 60 amps at 0.8 power factor lagging, calculate the primary current and its power factor. In this example problem, so the transformation ratio, that means turns ratio, transformation ratio or turns ratio V2, V1. Here the supply voltage at HV side. So now see here the load current is given 60 amps, 8.8 power factor lagging, and the no load primary current by 0.6 amps, and at no load condition power factor is 0.27. Here the given data, V1 is 2200 volts, E2 is 220 volts, I0 is 0.6 amps, cos pi naught is 0.275, and I2 is 60 amps. Cos pi 2 is 0.8 lagging. 0.8 lagging. So here pi naught is cos inverse 0.275, that is equal to 75 degrees. Pi naught is cos inverse 0.27, that is equal to 75 degrees. Pi 2 is equal to here cos inverse 0.8, that is 36.86 degrees. This is the load power factor. This is load power factor, load angle, and this one is pi naught is no load angle. So here I2 is, that means I2 dash, this is in general we can write I2 dash, I2 dash. I2 dash is nothing but that is called K into I2. K into I2. What is a K here? V2 by V1. So that is equal. So K into I2, 220 by 2200. So which gives the 1 by 10 into 60. That means 6 amps. So here I0 is already given 0.6, and from the no load power factor the angle is 74 degrees. Here the written minus y minus, it is lagging. This minus is for lagging. Lagging. So now here I2 also minus 36.86 degrees is 6 angle of minus 36.86. So here minus is for lagging power factor. So from these equations, so here I1 is equal to I0 plus I2 dash, I0 plus I2 dash. So here I0 is 0.6 angle of minus 74 degrees plus 6 angle of minus 36.86 degrees. So this is in polar form. Convert by calculating this polar form into rectangular form, will get so 4.965 minus j 4.175, that is equal 6.487 angle of minus 40 degrees. So this is the I0 I1 value. This is the I1 value. So I1 is I1 magnitude is 6.487 and angle is minus 40 degrees. Here minus 40 degrees means it is lagging. So that means it is inductive load. Here now this is the minus 40 degrees is the angle between the voltage and current. That means the cosine angle between the voltage and current at primary side V1 I1. The cosine angle which gives the primary side power factor. See here the primary side power factor cos of 40 degrees which gives the 0.765 lagging. Here 0.765 lagging. So in this previous case, see here no load power factor is 0.275 and here at secondary side the power factor is 0.8 lagging at full load. This is no load and this one is full load at secondary side, and here 0.765 is a power factor at primary side. So 0.8 is in previous point, 0.8 power factor is lagging at secondary side. This is the primary side 0.765 lagging power factor. Now go for Example 2. A 400 by 200 volts single phase transformer is supplying a load of 50 amps at a power factor of 0.866 lagging. The no load current of 2 amps at 0.208 power factor lagging. Then calculate primary current and primary power factor. So here the given load of 50 amps I2, the power factor is 0.866 and I0 is given 2 amps, that is 0.208, so power factor. So here calculating the primary current, how can we calculating? I1 is equal to I0 plus I2 dash. So I here I1 is equal to I0 plus I2 dash. I1 is equal to I0 plus I2 dash. So this is the formula. I2 dash is nothing but K into I2. K is, so V2 by V1. See here, the solution given data is V1 is equal to E1, that is 400 volts. E2 is 200 volts. I2 is 50 amps. Cos pi 2 is 0.866 lagging. So here I0 is 2 amps. Cos pi 0 is 0.208 lagging. Pi 2 is cos inverse of 0.866, that equal to 30 degrees. Sin 30 is 0.5 and pi 0 is cos inverse of 0.208, that is 78 degrees. Sin pi 0 is 0.978. See here, the primary current I1 is equal to I0 plus I2 dash. So I2 dash is equal to K into I2. Here K is 200 by 400 and I2 is 50. So 200 by 400, which gives the 1 by 2 into 50. That means it is 25 amps. So I2 dash is 25 amps. 25 amps. Now I2 dash is 25 angle of minus 30 degrees. Minus 30 degrees it is lagging. And I0 is 2 angle of minus 78 degrees. So here in this equation I1 is equal to I0 plus I2 dash. So here all are given in polar form. So we are converting polar into rectangular form, so which gives the answer. Then after go to the polar form. Here I0 is 2 angle of minus 78 degrees plus I2 dash is 25 angle of minus 30 degrees. 2 cos minus 78 degrees plus j 2 sin minus 78 degrees plus 25 cos of minus 30 degrees plus j sin minus 30 degrees. That is equal to 0.416 minus j 1.956 plus 21.65 minus j 12.5. Here the 0.416 and 21.65 are added, so it is getting some value, that is the 22 point something and also minus j 1.956 and minus j12.5 will give the, so 12 plus 1 plus, so it is approximately 14 point something. So this rectangular form will converted into the, so polar, so which is gives the, that is nothing but 26.38 angle of minus 33.22 amps. So here this is the phase angle between the voltage and current between V1 and I1. So which gives the power factor, that is cos pi 1. This is the pi 1 angle. This is the V1 I1 angle is pi 1. V1 I1 angle is pi 1. So cos pi 1 is cos of 33.22. So the primary power factor is the cosine of the angle between V1 and I1. So cos pi 1 is equal to cos of minus 33.33 degrees, which gives the 0.836 lagging. So this is the answer, so for this problem. And so next go for example 3. Here a single phase transformer 1000 by 250 volts draws primary current of 25 amps at 0.707 power factor lagging and secondary current of 80 amps at 0.8 power factor lagging. So here calculate the no load current of transformer and its phase with respect to the voltage from the phasor diagram. So here what they given in single phase transformer 1000 volts by 250 volts draws primary current of 25 amps at a 0.707 power factor. Here they given primary current, that means I1, and the power factor is pi 1 is cos pi 1 is 0.707. From that we can calculate, so pi 1, and also secondary current of 80 amps. So I2 is given, that is 80 amps, and also power factor also given 0.8. So we can calculate the, from this we can calculate the no load current. See here, solution given data V1 E1 are 1000 volts, E2 250 volts, and I1 is 25 amps, and cos pi 1 is 0.707 lag, and also I2 is 80 amps and cos pi 2 is 0.8 lagging. Solution pi 1 is equal to cos inverse of 0.707, that is pi 1 is 45 degrees. Here this is the degrees, not this is the degrees, not 450, it is 45 degrees. Now pi d is cos inverse of 0.8, that means 36.9 degrees. I2 dash is equal to K into I2. Here I2 is given, so 50 by 1000 into 80, that is nothing but 20 amps. So here I0 is nothing but I1 bar minus I2 dash bar. So here 25 angle of minus 45 degrees minus 20 angle of minus 36.8 degrees. So here 17.68 minus j 17.68 minus 16 plus j12, which gives the 1.68 minus j 5.68. That is equal, it is now good into polar 5.92 angle of minus 73.52 degrees. Therefore, the magnitude of the no load current is 5.92 and its phase is minus 73.52 degrees. Minus 73.52 degrees. So now another example problem. The secondary of a single phase transformer is supplying a current of 300 amps at a power factor of 0.8 lagging. The no load current of the transformer is 5 amps at a power factor of 0.2 lagging. So calculate the primary current and its power factor. Assume the transformation ratio to be 3 and neglect the voltage drop due to the impedance of the windings. The solution. So given data, I2 is given, that is 300 amps, and cos pi 2 is 0.8 lagging, I0 is 5 amps, cos pi 0 is 0.2 lagging. From that, k is equal to 3. So pi 2 is cos inverse of 0.8, 36.86. Pi 0 is cos inverse of 0.2. That is 78.46 degrees. I2 dash is equal to k into I2, that is 1 by 3 into 300, which gives the 100. So now I1 bar is equal to I0 bar plus I2 dash bar. So 5 angle of minus 78.46 plus 100 angle of minus 36.86. So here 1 minus J4.89 plus 80 minus J60, that is 81 minus J64.89, that is equal to 103.78 angle of minus 38.73. So therefore, the magnitude of the primary current is 103.78 amps and its power factor is cos 38.73 degrees, that is 0.78 lagging. So here we have discussed about the concept of various currents in the windings of a transformer, the procedure to solve the problems on current and power factors of a transformer, assuming the windings have no leakage impedances. So quiz. So what is done to be balance the MMF set up due to the secondary current? So here the primary voltage is increased, the core flux increases immediately, and the current in the primary increases. These are all correct. Which of the following applies to an ideal transformer? Coefficient of coupling is unity. Permeability is core is infinity. Yes. Copper and core losses are 0. Yes, all are correct. The no load power factor angle is close to 90 degrees because magnetizing is more than that of the working component of current. So IW is less than I mu. The frequently asked questions are, these are the questions at 2200 volts to 2200 by 200 volts single phase transformer takes 1 amps. At the HT side, no load at power factor is 0.385 lagging. Calculate the iron losses if the load of 50 amps at a power factor of 0.8 lagging is taken from the secondary of the transformer. Calculate the actual primary current and its power factor. These are the example problem. And next one is a 400 volts by 200 volts single phase transformer is supplying a load of 25 amps at a power factor of 0.866 lagging on no load. The current and power factor are 2 amps and 0.208 respectively. So calculate here the current taken from the supply. These are the frequently asked questions. See here. See the problem. Thank you.